everybody, welcome back to another session of teaching calculus remotely. So today's stuff that I'm going to look at is just a little bit of rules to help you out with your limits so that hopefully everything will work out. Remember that you can of course do graphing, you can of course make a table, but sometimes algebra is just going to be a little bit faster. So let's take a look at some of the stuff. So our goals for today are evaluate a limit using some properties to help you, and develop and use some strategies for finding limits. So the first rule that we have up here says the limit of f of x as it approaches c does not depend directly upon the value of c. However, you may find it helpful to try some of these different techniques to help you. Like for example, first thing that's up here is direct substitution. So this is one that I always try with limits, is if the limit's pretty simple, I'm just going to substitute directly whatever that number is, and that's going to tell me the limit. Now, let's talk about just a few of the little basic rules here. So the first rule that's here that says that if I'm taking the limit of b and b equals b, now I want you to notice down here at the bottom, x equals c. There's no x at all in this problem. So if your limit is a constant, it is just equal to the constant. Let me show you what I'm talking about here. I've got the limit of 3. There's no place to substitute that 2 into, so my answer is just 3. Okay, so if you were to happen to run across one of these little oddballs, you're just going to say to yourself, okay, it's a constant. I've got no place to put the x, so my answer is just 3. Now the next one, this one kind of throws people off a little bit. Remember that you're just substituting. So it says that if you put c in place of x, you will just get c back out. Okay, what does that look like? That's this example. So if I just take -4 and I put that directly in where my x is, I just get -4. So it's just like getting x to the first power. So these are just some very basic things. Our last one of this group is substituting in if you have another power. So an n power is like, could be squared, cubed, whatever. Looking at our example that we have here, I'm just going to take that 3, I'm going to substitute it right in, and my limit is 9. See, very straightforward. We've got a constant, we've got an x to the first power, we have an x squared. All three, well, okay, so the first one really didn't use substitution, but the remaining two use substitution. Now the stuff down here at the bottom, some of you will find that helpful, and some of you are going to look at it and go, I just don't really need all of this extra detail, but I want to make sure that you have it available. So first thing is we've got scalars. So if you have a scalar multiplier like b, when you substitute in your value that you have there, it's just going to be b times whatever the limit is. So for example, if I were taking the limit as x approaches 2 of 5x, my scalar is 5, so that's just 5 times 2. See, notice times 2. So I just end up with 10. It sounds more complicated than it is. Now this one here, this one is kind of helpful if you need to split your limit into 2 separate parts. So for example, if I had the limit as x approaches 2 of 5x plus 2, if I wanted to, I can deal with those separately. I'm going to tell you most of the time I don't. I still just substitute and I end up with 12. But this allows you, if you wanted to, you could take the limit first of this piece and then of this piece and then add them together. It's kind of okay, but it's not all that amazing. Now this one's going to tell you right here, this is your multiplication rule. So if you have 2 separate things that are multiplied together, you can find the limit of them separately and multiply them. So let's just say that, and again, this is kind of a weird situation. You have the limit as x approaches 2 of 5 times x. If I want to, I can find the limit of 5 and then find the limit of 2 and then multiply those together. But again, I'm going to tell you, I don't use it very much. I just go ahead and substitute, And I'll tell you 99% of the time, you don't really need that product rule. Quotient rule is the same thing. It allows you to do things that are divided. So if I were to do that, it'd be limit as x approaches 2 of 5 divided by x. If you want, you can do the limit of 5 and then find the limit of the x. But again, I just really feel like substitution is really just the best approach on that. And then our last one is the power rule. So if I have, let's see here, the limit as x approaches 2 of, let's say x to the 3rd power. Again, it's just going to say that it's going to be whatever your limit is to the 3rd power. It's still just a substitution problem. So why are these rules here? They're just to let you know that when you go into theoretical calculus, you have all those options. So let's go down here and look at this. If I wanted to, I could change this into the following problem. See, look, I'm going to use that addition rule here. But what I'm going to tell you is you're going to get exactly the same answer as if you just did substitution. So if you just do 4 times 2 squared plus 3, you're going to get the same answers if you drag it out really long. So that's going to be 4 times 4 plus 3, so 12 plus 3, 15. So why did I take the time to talk about these rules? Because I know that some of you will be taking more calculus classes, and it's important that you've seen it once. Again, I think your most powerful tool that you have in your disposal, substitution. Okay, so some of this stuff is just going to talk you kind of through this with the rules. If you're taking the limit of a polynomial with rational functions, that's what that guy is right there. Okay, that's a polynomial rational function. What it tells you is that you may want to do a little simplifying, if you can, beforehand, before you substitute. So if I go and you always want to try substitution first, and if substitution doesn't work, you can do some algebra. But this rule tells you that when you're doing this, you want to substitute in the numerator and substitute in the denominator. That's all it's telling you. It's the most complicated way possible to tell you to just substitute. But see, look at that. It's just telling you the limit of the overall function is whatever you get on the top divided by whatever you get on the bottom. That's what I'm doing right here. So 1 plus 1 plus 2, that's 4 over 2. Notice that's right there. And you end up with just 2. Substitution is your best friend with limits. Now, let's talk a little bit about radicals. Just so you are aware, here is your rule for your limits with radicals. It just says substitute. Yeah, that's the sum total of what you see in here. Substitute, okay? Now, when you get down to this one, again, you've got a function within a function. What it says is take the limit of the inside function, then do the outside function. That's what you see here. Again, this is just another way to say substitute. Let's slide on down here and let's actually do that substitution. So if I want to do a radical, I don't know why I rewrote that, but I did. That happens sometimes. I'm going to substitute. So I got the square root of 0 squared plus 4. So that's the square root of 4, which is just 2. Okay, real straightforward there. Same thing over here. This one's a cube root, so do watch out a little bit there. So you're going to have 2 times 3 squared minus 10. And I hope that's something I can cube root. If not, I'll leave it uncube rooted. So let's see here. That is 9 times 2, 18. Minus 10, that's 8. Yes, I can cube root that, and I get a 2. So notice there's all sorts of rules, all sorts of them here, just tons of them. But pretty much your biggest thing, substitution. If you substitute, you will not be unhappy. Now, with these are just some extra ones. I will tell you that when you're looking at the curriculum for your class, it specifically does not deal with cotangent, secant, or cosecant. It focuses on sine, cosine, and tangent. But again, what are you going to do? Substitute. So this one is tangent of 0. And we're going to simplify that in just a minute. Over here on this one, we have pi times cosine of pi. Again, I'm going to substitute that, clean it up in just a second. We have sine squared of 0. And then down here, oh no, if I substitute in, that's going to be a little bit of a problem. I'm going to come back to that one in just a moment. Let's focus on those trig functions. So if I want tangent of 0, so you want to think about your unit circle right over here where it's at 0, right there, 0 radians. Remember, everything we do in calculus is in radians, no degrees. So your coordinates right there are 1, 0. And tangent is sine over cosine, in case you forgot. So the sine value there is 0. The cosine value is 1. So the overall value of the limit is just 0. Now let's talk pi. Okay, pi's over here. That's where it is, right there. And those coordinates are -1, 0. All right, so that'll be pi times -1, so negative pi. And then our last one over here, we're going back to 0. We wrote those out over there, but just kind of to keep it consistent. There's 0. And remember, our coordinates here are 1, 0. So one thing I do want to point out to you is that it may help you when you see a square to rewrite it that way. So our sine value is 0, then we square that, we still get 0. So that was a little disappointing. Now let's go down to our very final example. Okay, last one. Now on this one, when I try substitution, I get a not pretty answer. I get 0 over 0. That's not okay. So you're going to have to do a little bit of work with this one. So up on the top, you have difference of cubes. Now when you factor that, and yes, I'm going to write out that formula. I better do it right now, shouldn't I? Cubes. That formula is A minus B, and then A squared plus 2AB plus B squared. So let's do a little fill-in on this. So you're going to have x minus 1. That's your A and your B. Then you're going to have x squared plus 1x. So I'm just going to write an x. And then you're going to take that -1, you're going to square that, you get a positive 1. All over x minus 1. And you're taking the limit as x approaches 1. Now, let's talk about that trinomial. It will never factor. Don't waste your time. Instead, cross out the two things that you have in common and then substitute. So this becomes 1 squared plus 1 plus 1. So you end up with 3. Now down here at the bottom, it says strategies. So it says learn the theorems, but remember all the theorems point to direct substitution. Next, when a limit cannot be evaluated with direct substitution, see if you can possibly do a little algebra to it, okay? What happens if algebra fails? Use a graph or a table. So I always do substitution, then I try algebra, and then finally I will try a graph or a table. I typically do not reach for my graph or my table unless something is very complicated and I cannot figure out how to do substitution with it. All right, so that's your stuff. Make sure you do those problems up here at the top, which is page 67, numbers 5 through 37. Remember, if you need help, please schedule an extra help session with me. Do not wait until you are so far behind on limits that we can't even see how long ago it was. And I hope you all have a great day.